Welcome to my channel RAVIKUMAR Academy. This is a lecture series on ordinary differential equations of first order and first degree. In this lecture, we are going to learn the general form of a ordinary differential equation of first order and first degree, necessary condition for exactness of a differential equation, and how to solve an exact differential equation. The ordinary differential equation of first order and first degree will look like dy by dx equal to some f of xy, right? So here the first order is 1 and degree also 1. Now let us write this f of xy as some m of xy by n of xy. We can write it like that. Then multiplying, cross multiplying, you will get n of xy dy equal to minus m of xy dx. So that you can write it as m of xy dx plus n of xy dy equal to 0. So this is the equation that we are going to deal with in the coming videos. So simply we call it m dx plus n dy equal to 0. Now necessary condition for exact. When do you call this equation 1 to be exact differential equation? Suppose we are given, when do you call this equation exact? It is dou m by dou y equal to dou n by dou x. So if dou m by dou y equal to dou n by dou x, then equation 1 exact differential equation. Okay. Otherwise we call it as non-exact differential equation. Okay. Then how do you solve? What is the solution of this equation 1? Once it is exact, proven to be exact, the solution looks like integral m of xy dx, keeping y as constant. Y is constant. That means throughout this integral, we keep y as constant. Plus integral terms of n of xy not containing x, not containing x dy equal to c. So this is the solution of the equation 1, exact differential equation. Okay. Now we will solve some problems related to this. Suppose this is the problem we are given. Now how do you write here? You compare this with m of xy dx plus n of xy dy equal to 0. So when you compare this equation with this, in place of m of xy, we have e power y. So m of xy is e power y, and in place of n of xy, we have x e power y plus 2y. Okay. Now, what is dou m by dou y? Dou m by dou y is e power y, because the derivative of e power x is e power x with respect to x. Here with respect to y we are doing. So what we have to check, whether it is to check the exactness of the equation, dou m by dou y equal to dou n by dou x. Now we have found dou m by dou y. Now it is a partial derivative of m with respect to y. This is partial derivative of n with respect to x. We are differentiating with respect to x. Dou by dou x of x, n. N is x e power y plus 2y. Because we are differentiating with respect to x, e power y becomes constant. So you can take it out. You can take e power y out and write dou by dou x of x plus Taking dou by dou x to the second term, dou by dou x of 2y. Here dou by e power y into dou by dou x of x. Dou x by dou x is 1. Plus there is no x in this term, therefore the derivative is 0. So it is e power y. So therefore dou m by dou y is equal to dou n by dou x. This implies equation 1, this one, name it as 1. Equation 1 is an exact differential equation. Exact differential equation. Now what is the solution of the exact differential equation? This one is the solution. So therefore the solution of this equation is integral keeping y as constant throughout this integral. Let us write the formula first. You should always write the formula to get some marks. You may be given 1 or 2 marks for the formula. Right. Terms of n not containing x. Every time you solve the problem, you write the formula. Dy equal to constant. So integral m of xy. What is m of xy? M of xy is e power y. N of xy is x e power y plus 2y. So m of xy is e power y dx. But remember here y is constant. That means throughout this integral we treat y as constant plus integral. Here terms of n not containing x. That means in the function n, we should consider only terms not related to x. That means we have terms of n containing x is this. This term is not containing x. Therefore, we should take this one only. Right? So, second term only. Then it is first term we should not consider. The second term is 2y. dy equal to constant. Right? Here x e power y plus 2y. In that term not related to x is this only. So that's only we should take. This implies e power y you can take it out. Integral 1 dx. Why should we take it out? Because everything related to y is a constant here. In the first integral, we are integrating with respect to x. Therefore, e power y is independent of x. You can take it out as a constant. Right? So 2 you can take it out. Integral y dy equal to c. Then e power y into what is integral 1 dx? X plus 2 into integral y dy is y square by 2 equal to c. So that implies x e power y plus y square equal to c is the required answer. Okay. Now we will see a different one. Here I am directly writing m of xy as 3x square y plus y by x, and n of xy, the second function, is x cube plus log x to the base e, and it is not given anything in the base, it is e. Now dou m by dou y we should consider first. Dou m by dou y of m is 3x square y plus y by x. We are differentiating with respect to y partially. Therefore, everything related to x, we should treat it as a constant. So here 3x square becomes constant. 3x square becomes constant. Then dou by dou y of y plus 1 by x is a constant. Dou by dou y of y again. Here also y. So this is 3x square into dou by dou y of y is 1. Here also 1 by x into 1. So therefore 3x square plus 1 by x is dou m by dou y. Next, what is dou n by dou x? Dou n by dou x is dou by dou x of n. N is x cube plus log x to the base e. And what is the derivative of x cube? It is 3x square. Because derivative of x power n is n into x power n minus 1. And dou by dou x of derivative of log x is 1 by x. So therefore dou n by dou x is this. Therefore dou m by dou y is equal to dou n by dou x. This implies equation 1. This is equation 1. Name it as equation 1. Equation 1 is an exact differential equation. Exact differential equation. Now, how do you solve this equation? It is, the solution is, once it is proved to be exact, the solution becomes integral m dx. I am not writing m of xy in detail, it is simply m dx. M dx, y is constant, y is kept constant throughout this integral, plus integral terms of n not containing x, dy equal to constant c. Now let us take the first integral where y is constant, m dx. What is m here? M is 3x square y plus y by x. 3x square y plus y by x dx plus integral. In the second integral, we should neglect the terms related to x. So in both the terms, you have x is present. Therefore, in the second integral, we have no terms related to x. Therefore, 0 dy equal to c. This implies in the first integral, you can split this integral into two parts, where 3x square y dx plus integral y by x dx equal to c. In both the integrals, we should keep y as constant. Y as constant. So here, because y is constant, 3y becomes constant. You can take it out. Integral x square dx. X square remain inside the integrand. Plus, you can take y constant with y out. It is 1 by x dx equal to c. So this integral is 3y into integration of x square is x cube by 3 plus y into integral 1 by x is log x. Of course, log x to the base e equal to c. So you can cancel out 3 here. So the answer is x cube y plus y log x to the base e equal to c is the required answer. Okay. So you should remember these two formulas here. Integral x power n dx is x power n plus 1 by n plus 1. And derivative of x power n is n into x power n minus 1. So these two formulas we use very frequently. Coming to this problem, this is a different one. Here in this lecture, I am covering actually 5 problems. All 5 problems are different 5 scenarios. Okay, please don't miss any of the problems. Here, this is a different problem because you see, carefully observe. You are given a function and you have dy here, another function dx. So in hurry, we do a mistake in common that we consider this as m and this as n. That should not be done. Okay. So you should be careful in dealing with this kind of problems. You multiply everything by -1, you will get here plus, here you will get minus. So convert this equation first of all into m dx plus n dy, sin y plus y sin x dx minus cos x minus x cos y dy equal to 0. In that case, m becomes sin y plus y sin x. You should always remember that the function that is adjacent to dx must be n and the function that is adjacent to dy must be n. So here n equal to, you multiply this function by -1, right? You have -1 here. So you will get minus cos x plus x cos y. So then dou m by dou y, we are differentiating with respect to y. So therefore, the sin y derivative is cos y. And the second term, sin x is a constant, you can take it out of this product. And the derivative of y with respect to y is 1. So this is cos y plus sin x or sin x plus cos y. Now here it is dou n by dou x. We are differentiating with respect to x. The derivative of cos x is minus sin x plus we are differentiating with respect to x. So cos y is constant into derivative of x with respect to x is 1. So this is minus into minus plus sin x plus cos y. Here also sin x plus cos y. Therefore, dou m by dou y is same as dou n by dou x. This implies equation 1 is an exact differential equation. It is an exact differential equation. Equation 1. Now, so how do you solve this equation? The solution is of the form integral m dx, here keeping y as constant throughout this integral, plus integral terms related to or terms of n not containing x, not containing x, dy equal to c. But what is m here? M dx, here m is this thing, sin y plus y sin x, sin y plus y sin x, sin y plus y sin x, keeping y as constant, y is constant, dx plus integral terms of n not containing x. Both the terms are containing x. Therefore, there are no terms not containing x. 0 you will get here. Dy equal to c. Because y is kept constant in this integral, you can take it out. You can take sin y out. Integral 1 dx plus, if you split this integral, you will get integral y sin x. Here also you can take y out. Then it is integral sin x dx equal to c. So it is integral 1 dx is x sin y plus y into integral sin x is minus cos x, is minus cos x equal to c. Therefore, the solution is x sin y minus y cos x equal to C is the required solution. Coming to this problem, we are not directly given the problem in the form of m dx plus n dy, but it is dy by dx equal to y minus 2x by 2y minus x. You cross multiply, you will get 2y minus x dy equal to y minus 2x dx. Right? Now you take this one to the right hand side, you will get y minus 2x into dx minus 2y minus x into dy equal to 0. Here m equal to y minus 2x, n equal to minus 2y plus x. You should not forget this minus. This is very important. Okay. Then dou m by dou y is 1 minus 0, 1. Dou n by dou x, differentiating with respect to x, 0 plus 1, 1. So therefore, dou m by dou y equal to dou n by dou x. Therefore, equation 1 is an exact differential equation. It is an exact differential equation. This equation, name it as 1. Here we are given another condition also, that is important. Okay. Don't forget this condition. Now, the solution is of the form integral m dx plus integral terms of n not containing x, not containing x dy equal to c. And here in the first integral, y should be kept as constant. Integral, what is m? M is y minus 2x. You always search for m and n here only. Okay. After simplification, you will get m equal to y minus 2x. So here you will get y minus 2x dx, keeping y constant, plus terms of n not containing x. What are the terms not containing x? Terms of n other than x, it is minus 2y only. Okay. So you have minus 2y dy equal to c. So here y is kept constant. So 1 dx, distributing this integral to the two terms. The second term, it is 2 is a constant, integral x dx. Minus 2 comes out of the integral y dy equal to c. So it is xy, because integral 1 dx is x, xy minus 2 into x square by 2 minus 2 into y square by 2 equal to c. So you can cancel out 2 here. Therefore, xy minus x square minus y square equal to c, the required answer. But what you are asked to prove? You are asked to find the solution which satisfies y of 1 equal to 2. So using this type of, whenever you are given this type of question or condition, you will need to find the solution which satisfies this condition, y of 1 equal to 2. So what is the condition given? Y of 1 equal to 2. When you put y of 1 equal to 2 means what? At x equal to 1. When x becomes 1, right, y becomes 2. X equal to 1, y equal to 2. Put x equal to 1 and y equal to 2 in the obtained solution. You will get 2 minus 1 minus 4. 1 into 2, 2 minus 1 square minus 2 square equal to c. So this implies 2 minus 5 minus 3 equal to c. C equal to minus 3. So therefore, the solution becomes xy minus x square minus y square equal to minus 3, or let us take everything to the right hand side. X square plus y square minus xy minus 3 equal to 0. So this is the required solution. Now let us solve the last one. It's a different kind of problem. Here also m equal to, you take the first function that is adjacent to dx as m. It is sin x into cos hy. N equal to minus cos x sin hy. Right? What is dou m by dou y? Because we are differentiating with respect to y, sin x is a constant, it comes out, and the dou by dou y of cos hy. What is the derivative of cos hy? Sin hy. So sin x into sin hy. And what is dou n by dou x? Differentiating with respect to x, you can take minus sin hy out, and dou by dou x of cos x, this is minus sin hy multiplied by derivative of cos x is minus sin x. Therefore, minus into minus plus sin x into sin hy. So thus, dou m by dou y is equal to dou n by dou x, implies equation 1 is an exact differential equation. Exact differential equation. Equation 1 means, let us take this as 1. Now, what is the solution? How does the solution look like? It is integral m dx plus integral terms of n not containing x, dy equal to c. Here y is kept to be constant throughout this integration. So here y is constant. M, what is m? M is sin x into cos hy. Sin x into cos hy dx plus integral terms not containing x. But in the second function n, we have only one term which is having x. So you cannot take it. So put the 0 in place of integrand. Then we are keeping y as constant, therefore you can take cos hy out of the integral. Integral sin x dx equal to c. Integral sin x dx is minus cos x into cos hy equal to c. Let us take negative c, so that c1. In that case, the answer is cos x cos hy equal to c1. So this is the required solution. This is all about exact differential equations. Please subscribe to my channel if you have not subscribed it. Please like the video, share it with your friends and classmates, comment your feedback in the comment section. And if you want to learn any new concept, please let me know in the comment section. Thank you.